Let's solve this problem. They have given that page size equal to 8 KB, page table entry size is equal to 8 bytes, and outer page table, see what do they mean by outer page table? The last level page table, right? The first level page table, second level page table, and the last level page table. That is what we have been doing so far. And they are saying the outer page table size equal to 8 KB. And they have also given that we are using two levels of paging here, which means two levels of page tables are created apart from process. Also they are saying that assume that except the outer level page table, all the pages of inner page tables are completely full. And they are asking what is the total size of logical address space, which means what is the total size of our process. That's what they are asking. See, they have given two levels of paging, right? So I'm taking level 2 page table, level 1 page table, and our process, right? These are the three things, three levels we will have. We have two levels of paging, along with it we have process, fine. Also they have given that outer page table's total size is 8 KB. Outer page table, see the total size of page table is 8 KB. Also they have given that size of single entry is nothing but 8 bytes. So from this we can say that total number of entries in outer page table is nothing but page size divided by page table entry size, right? See, page size is nothing but 2 power 13 bytes divided by page table entry size. They have given it as 2 power 3 bytes. So 2 power 13 divided by 2 power 3 is nothing but 2 power 10. So we have a total of 2 power 10 entries in this level of page table. What does it mean? Which means in level 1 page tables we should have had 2 power 10 pages, right? See, only in case if we have 2 power 10 pages over here, we should have maintained 2 power 10 entries in this page table, right? Because for every level of page for every page over here, we maintain an entry in this level. So number of pages over here is nothing but 2 power 10. So we have a total of 2 power 10 pages over here. And also we know that a single page can hold 2 power 10 entries, right? Because page size is 2 power 13 bytes and page table entry size is 2 power 3 bytes. So in a single page, we can have a maximum of 2 power 10 entries. So in first level page table, we have 2 power 10 pages, fine. And every page will have 2 power 10 entries, right? So the total number of entries in level 1 page table is nothing but number of pages into number of entries per page, right? Number of pages into number of entries per page. Number of entries is nothing but 2 power 10 and number of entries per page is nothing but 2 power 10, right? So this is the total number of entries we will have in first level page table, right? See, page and page will get cancelled here, right? Fine. So we will have a total of 2 power 20 entries in this level of page table, right? See, in case if we have 2 power 20 entries in this level of page table, what does it mean? We will have 2 power 20 pages in our process, right? Why? Because for every page over here, we will maintain an entry in this level, and it has been given that we will have a total of 2 power 20 entries in this level. It means what should have happened is we should have had 2 power 20 pages in our process, right? So number of pages in our process, same, I'm speaking about process, right? Number of pages in our process is nothing but 2 power 20 pages. And we know that size of a single page is nothing but 8 KB, right? Which means page size is nothing but 2 power 13 bytes. 2 power 13 bytes. Now what is the logical address space? Logical address space is nothing but number of pages into page size or number of bytes per page. Both are same, right? Page size or number of bytes per page, both are same. This will give us the total size of our logical address space, or this will give us the total size of our process, right? See, number of pages is nothing but 2 power 20, 2 power 20 pages into page size is nothing but 2 power 13 bytes per page, right? Because we are speaking about single pages size. So page and page will get cancelled, and this is nothing but 2 power 33 bytes, right? See, 2 power 33 bytes is nothing but 2 power 3 is 8, right? 2 power 3 is 8 and 2 power 30 is GB, right? So it is nothing but 8 gigabyte, right? So the total size of our process is nothing but 8 GB, or we can also say that the logical address space size is nothing but 8 GB, right? Fine. So this is how we calculated the total size of our process. See, why they have given this is, assume that except the outer level page table, all the pages of inner page table are completely full. Is what they really mean by this is, see, here we will have lot of pages, right? This level of page table will have lot of pages. Now we know that there is a chance that our last page in this level can suffer from internal fragmentation, right? It can definitely suffer. When can this happen? See, this can happen in case if we don't occupy this page with entries, right? We don't occupy this complete page with entries. In case if we occupy only some part of this page using page table entries, which means we have lesser number of entries, this will lead to internal fragmentation, or this page will not be completely occupied, right? If this is not occupied, number of entries in this level of page table will decrease, right? Number of entries in this level of page table will decrease. If this decreases, then the number of pages in our actual process will decrease, right? The number of pages in our actual process, see, number of pages in process will be equal to number of entries in this level, right? If number of entries in this level decreases, then the number of pages in our process will also decrease, right? And if the number of pages in our process decrease, then the size of our process will also decrease, right? If we decrease the number of pages in our process, then the size of our process will also decrease. So, but in case if we have the scenario, we will not be able to compute the exact result, right? Why? Because we don't know how many entries we really have, right? In case if we have 2 entries in the last page of this level, we will have 2 entries over here, and so the process size will be something. Whereas in case if we have 3 entries over here, the process size will change, right? So we will get multiple answers in case if they didn't give this line, right? So just to restrict us to one answer, which means just to make sure that all of them will get the same answer, what they have done here is they told that except the outer level page table, except this level of page table, all the page table will be completely full. Now here we will not have internal fragmentation, and so the number of entries over here is fixed. We can definitely tell how many entries will be present, right? We have seen it, 2 power 20 entries. If there are 2 power 20 entries over here, then our process will definitely have 2 power 20 pages, right? Now if our process size is 2 power 20, if our process has 2 power 20 pages, then we can calculate the total size of our process, which means the logical we will get only one value for logical address space by mentioning this line, right? In case if they didn't mention this line, we will not be able to find out how many entries is present in level 1 page table's last page, right? If we don't know this, then we will not be able to know how many pages our process will have. In case if we don't know how many pages our process will have, we cannot calculate the total size of our process, right? That is why they have given this line. Fine.